Hi, here we are in the beautiful city of Valencia. Not exactly apparent, is it, that we are in Valencia? We're in a rather small, uninspiring room, but we are actually in Valencia at Euromembrane 2018, and I'm very happy to welcome to the latest MBR bio none other than Professor Anja Drews.
Thank you very much, Simon.
Thank you for coming. Always
Thanks
a
for
pleasure.
Me.
Well, thank you again for turning up. Of course, my opening question has to be that given that you are the only German I know, I think this has to be the case, with a faint Irish accent, which seems to be receding over the years. But
absolutely.
It's still there. So perhaps you'd like to sort of give the viewers a bit of background as to how that came about.
It is actually receding, all right. I shouldn't have spent time in Oxford, I think. That's probably
That's
my
what
fault.
ruined it for you.
Yeah, absolutely,
Okay.
absolutely did. Well, I acquired it in Dublin, of course. Where else would you? So I spent a year in UCD, studied chemical engineering as an undergrad, and that's where I got it. Many Irish friends.
Were you chemical engineering at UCD?
That's right, yeah,
Okay.
for a year. So.
And is that what first inspired you to get into wastewater, or was there some other formative things?
Actually, would you
went on in your
believe
life?
it was the first time I came into contact with membranes? I was at UCD. My first lecture on membranes ever
Really?
was at UCD. Yeah.
Who delivered that then?
Who delivered that? That would have been Dermot Malone.
Good grief. Okay. Well, you see, I've
You know?
learned something today already.
Hi, Dermot,
Okay.
in case you're watching.
Okay.
Yeah.
So good old Dermot.
Yeah,
That's what. So we owe the gift of your fantastic research to Dermot Malone. So thank you, Dermot, if you're around.
So yeah, I am a chemical engineer.
Sure.
A lot of people think I'm a biotechnologist or a water person. No, but I'm a chemical engineer by training.
Okay. Well,
Very traditional, you know.
very traditional. I'm a lapsed chemist myself. Nobody ever
Well, there.
believes that. But we all move on. So what happened after Dublin?
Well, after Dublin, I came back to Berlin and got my degree in Berlin, actually. So I didn't graduate from UCD. I got it in Berlin. And then I started a PhD. That was already a bio-related topic, not water-related yet, but bioprocess. And after that, I stayed on as a postdoc, and that got me into the field of wastewater and MBRs.
So when was your first foray into MBRs as a researcher?
That would have been around 2003, 2004, around that time. I was working with Sandra Rosenberger at the time.
Oh, right.
Because
Okay.
we did our PhD together in the same department, so yeah.
Good grief. Yeah, it all come. The memories come flooding
Hi,
back
Sandra.
now. Well, I guess you both ended up in sort of vaguely similar areas. I mean, she's also
Yeah,
a
that's
prop,
right. Yeah, yeah.
and obviously you've
She
been
does
a
a
prop
lot
for several
more
years.
energy, and I do more like bioprocesses. Again,
Okay, so you're back with bioprocessing
Yeah.
again. All right. So obviously you were part of the sort of the rich and very productive research that was going on in MBRs. I guess are we talking from the late 1990s now, or
early 2000s.
Early 2000s. There's a
Up
lot of
until
stuff.
2008 or something like that. Do you remember when we had the big European projects on MBRs?
Absolutely, yeah.
Yeah.
My memory has faded, so it was actually the mid noughties when that was
that's
going
right,
on.
yeah.
Okay. So what were you doing exactly in MBRs at that time?
Oh, we did several things. We had a couple of PhD students in that group in our lab working on fouling, working on flux enhancers, but also working like on BioP or post-notification. So many different things going on, different pilots. And my task was sort of to look over all this and, you know, find some general rules that apply to all those plants. And it was great because we had lots of data at the time.
There's a lot of stuff going on throughout Europe at that time,
absolutely.
wasn't there?
So
what do you think the main outcome was? I know it's a difficult question because you were doing so much, but I mean, is there any sort of like standout stuff that...
the main outcome is we don't see correlations at all.
between fouling and anything else?
Everything is so different.
I think you found that Jaap van der Graaf found exactly the same thing over about six or 8 years
the
of
European
research.
tour, I remember that, yeah.
Exactly, yeah, it's amazing times.
Yeah.
So no correlation between
absolutely.
fouling and anything else whatsoever. So there you are. If there are any PhD students doing fouling research in MBR,
But keep trying though,
heard
keep
it from the
keep
master.
trying.
Okay, so you've gone through that. When did you get to be a prof? I know you were at TUB for quite a while.
That's right, as a postdoc, yeah.
So what happened after that?
Well, you know, the German system, you are not permanent until you become a professor. So I had to leave at some stage, obviously.
All right.
So I went to Oxford for, in the end, only 9 months, because then I became a professor at HTV Berlin, as it's called. It's a University of Applied Science in Berlin.
And how long ago was that?
That was 2009.
Oh, right.
So I've been there now 9 years. Almost.
Oh, amazing. All right. Then what have you been doing? You must have been doing lots of different stuff. Were you still doing MBRs when you first went back to Berlin? Or?
I was supervising a bit of MBR stuff, but not wastewater related, so more enzymatic processes in membrane reactors.
Fancy stuff.
So absolutely,
Biochemistry.
absolutely, yeah. No, we didn't do any. Well, a little bit.
Okay.
So yeah, there were 2 PhD students who worked on that at TUB, which I co-supervised.
All right.
And yeah, but I've always kept a collaboration with Chung-Hak Lee.
Oh, in Seoul.
Yeah, that's right.
Right.
So we had a small project together, a joint project, and then now I'm hoping to get more money to keep collaborating with him.
Oh, marvellous. So he's still
Hi,
there.
Chung-Hak.
She's the worst name dropper I've ever come across. Well, that's amazing, because I naturally assumed he might have retired by now.
He is actually retired, yeah.
Oh, okay,
that's
but he's
right,
still he's still holding a candle for presumably things like. He's the guy that did things like microbiological, core and quenching, microbiological architecture of fouling on membranes.
Exactly.
I remember he did some pivotal stuff on that.
Right.
Okay, getting back to your work then. So, just can you sort of pick out any bits from the last 9 years since you've attained this professorial position that sort of like stand out again in terms of outputs? I mean, for example, I know that you did that standout review on membrane fouling, which I think was a sole authored thing. It's been it's very highly cited because you did the trick of sort of making the title a question, like.
Very clever.
Why are we all here? Or something like that. I can't remember exactly. But
and does it all matter?
Exactly. It was a very good and very succinct, mercifully succinct review of the sort of state of fouling at that particular time. So that's obviously something which certainly it sort of made an impression on me. But is there anything else that you've done?
Thanks very much.
Is there anything else that you've done, like in the last...
Well, I haven't done any work like that since then. I've moved on to other fields. So it's obviously too early to write like big reviews on the new fields I'm working on now.
So what sort of stuff are you doing now?
I'm still doing membranes, but not exclusively. I do, the overruling theme would probably be renewables. So how to make use of renewables, not to produce energy, but use them as chemicals. So we do enzymatic conversion or other catalytic conversion, sometimes coupled with membranes in those processes, sometimes not. And the stuff I've presented here now at Euromembrane was on the use of Pickering emulsions.
Right, that's where you use solids, fine solids to form the emulsion stabilizer.
Like nanoparticles or microparticles that stabilize the droplets.
Sure.
So we can nicely wrap the sensitive catalysts like the enzymes into a shell, into the droplet, and then make this liquid-liquid catalysis happen.
All right.
And the membranes, we then need to separate those phases to recycle the catalyst.
Right, well, I imagine the membrane, it sounds as though, I'm a complete philistine when it comes to things like this, frankly, but it sounds as though the membrane bit is not necessarily the most expensive part of the entire process if you're sort of like...
No, it's not. No, it's the catalyst.
So you can use any damn thing you like. It's gold-plated ceramic membranes, probably,
absolutely,
for that particular happenstance. Okay, well, given that you've got this very eclectic and wide view of membrane technology, the circular economy, and everything else. Where do you see membranes actually going in the future across the whole board? Obviously, you're very heavily into renewables, and membranes definitely play a part there. So where do you think they fit in the future?
Yeah, well, I mean, I'm sure there are many processes out there that we still don't know yet. I mean, having worked in this liquid-liquid catalysis field, it opened up a completely new world to me. So it is really difficult to answer where do membranes come in. I guess they can come in everywhere where we develop new processes. I mean, we can't think of these things yet. So...
But I mean, that's a fair enough. You use a membrane for just about anything.
Well, I wouldn't go as far as that. I know different colleagues would go to that extent. I wouldn't, but there are always alternatives.
There are always alternatives. You can use membranes for almost anything, but frankly, a lot of the time, there's no damn point.
Absolutely.
So I guess my main question is, do you think there's any specific opportunities for membrane technology within the whole gamut of renewables where you can think, well, actually, that has some legs as far as a future implementation is concerned. Because there are a lot of places where you can use membranes, but obviously 95% of the time it's
well, all the downstream processing, every time you need to fractionate, especially from like the vast variety of different molecules you have in those renewables, every kind of fractionation maybe is a field where membranes come in, or liquid, gas-liquid contacts, and all this kind of thing. I would think there's much more that we could do, especially with functionalized membranes.
Oh yeah, well, can you think of a specific one?
Actually, I'm not a material scientist, so I couldn't tell you, but no, I find it exciting to see what people do with membranes and what they stick in as fillers and
Well, yeah, I mean, there's all sorts of things.
That's not my field.
Facilitated
I don't have
transport. It's funny because Richard Baker was saying yesterday that we'd be doing. I'm dropping names now. Hi, Richard. I know you're not watching this, but he was saying with facilitated transport, that's been around for. I think it's been around for about 2 decades at least.
That's right. Yeah.
And implementation is almost completely absent, I would say. So there are some fantastic ideas, but clearly there are some high-value applications where a membrane does make sense, and in fact there might not be much alternative. I mean, obviously there are very obvious examples like desalination.
Yeah.
You either use an RO membrane or you boil the water.
Yeah.
That's it.
Exactly. That'll always be a big field, big market, but I mean, we know how it works, so...
Yeah, so that's done and dusted, but I'm just thinking, projecting forward in the future, market. Is there any sort of like cut and dried membrane application for a very specific, it might be quite niche area within renewables? Exactly,
that's what I meant, like niche areas in specific fractionations of specific molecules.
So what's the highest value product that you get from a renewable application in your experience, the sort of thing that you're actually working on?
Well, the things we're working on are long to medium chain olefins, because, you know, the mineral oils, they have short chain carbons, and if you want to use them as chemicals, it doesn't make sense to break down the long chain ones into the small bits and pieces and then reassemble them. So we might want to make use of them as they are. So we can do like terpenes, we can do all sorts of aldehydes, and, you know, things like this.
Marvellous.
Yeah, for cosmetics, detergents, what have you.
Well, what are you starting from then in producing those sorts of high-value products?
Well, we're starting from the oils in the plants, so the olefins. Yeah.
Oh, right. Well, on that particular note, that leads me to my final question, which is, where do you think you'll be going in the future with your research? I mean, you're still relatively young.
Thank you very much.
So where do you see yourself going with all this stuff?
I'm hoping actually to go back to MBRs, at least a bit.
You're just
not
saying,
exclusively.
she's just saying
I'm not. I kind of miss it. We have a rig set up and ready to run. We just need the funds to actually work on it.
That's fine.
But yeah, I mean, the other stuff as well, that's great. I mean, it's always nice to, you know, have 2 fields to play with, not exclusively focus on one.
Absolutely.
Because if funds run out, what do you do?
Yeah, exactly, yes, we have to be pragmatic in this particular trade.
Yeah.
Is there any particular aspect of MBRs that you think is worth looking at? I mean, you've obviously been there in the past and you've looked at an awful lot of different stuff within it. So is there anything in the future you think you should maybe focus on that might actually be remunerative in some way? You
want me to say clogging, is that right?
Not really, no. People just seem to avoid that subject completely. I've given up on that. Is there any particular aspect that... you sort of just think...
I personally am really interested in the multi-phase or the 2-phase, 3-phase flows as we have them. So I think we can do a lot still in module design through better understanding of the multi-phase flows in those funny, you know, non-Newtonian liquids. So that's great stuff. It's also nice to watch. I mean, you showed those bubbles before.
It is, yeah. It's like a lava lamp thing going on,
absolutely,
isn't it? And of course, the CFD modelers. We should do, yeah. That means the CFD modelers can go absolutely nuts on that, can't they? Because that's really quite a challenge.
But experimentally as well, it's great.
Yeah, I guess so. Yeah, marvellous. Well, anyway, thank you very much indeed for that really informative insight, and hope to bump into you again some other time.
Yeah.
Thanks. All the best.
Thanks a lot. Thanks.
Cheers. Bye.